We tend to think of artificial intelligence as ethereal software, code floating cleanly in the cloud. But building modern AI is actually a heavy industry, and like any heavy industry, it relies entirely on the massive extraction of raw material. That raw material is human language. AI developers have scraped hundreds of billions of words from the open internet, harvesting decades of accumulated books, academic papers, forums, news articles, and source code. This extraction project birthed the large language models we use today, like GPT-4 and Claude. By exposing software to the sheer breadth of human reasoning, researchers produce systems capable of writing, analyzing, and translating. We are currently experiencing an illusion of infinite technological progress, but that progress is the byproduct of a massive, finite resource grab. The open internet has a bottom. The strategy of scraping everything online is hitting a hard structural limit. This chart shows the exponential growth of AI data consumption colliding with the fixed supply of high-quality internet text. Researchers at Epoch AI estimate that, at current rates, the tech industry will completely exhaust its supply of usable public data by the year 2026. The first wave of AI development relied on an absolute abundance of data. Future growth now depends on navigating a severe industry-wide drought. You might wonder, since humans post billions of new words online every single day, how can we possibly run out of text? The constraint isn't quantity, it is quality and novelty. Most remaining untapped data is highly repetitive, poorly structured, or too niche to be useful. This flowchart illustrates the consequence of scraping the bottom of the barrel. Pristine data enters an AI, generating degraded synthetic text. That degraded output loops back to train the next model. This creates model collapse, a closed feedback loop amplifying errors and hallucinations. We've reached a tipping point. Feeding low-grade internet data into a model actively degrades its performance. Mining the bottom of the barrel breaks the machine. AI labs know the well is running dry. In response, they are deploying expensive solutions to find new fuel. The first attempted solution is synthetic data. Instead of harvesting examples from humans, developers use computers to generate artificial training inputs from scratch. But this approach has severe limits. It works for structured, verifiable tasks like mathematics and coding, but fails to produce the necessary nuance for open-ended human language. The second, more pragmatic solution is buying access. Tech giants like OpenAI and Google are rushing to sign multi-million-dollar licensing agreements with publishers to access gated archives. Tech companies willingly paying millions of dollars to read the news proves the central crisis. Free, high-quality data is officially extinct. The public commons of the internet successfully launched Wave 1 of artificial intelligence, but it cannot sustain the weight of the next phase. The world's remaining high-value, untapped data lives off the grid. It is locked inside corporate documents, private messages, medical records, and logistical systems. That premium information is secured behind strict legal and ethical walls. It is invisible to Silicon Valley's web scrapers. For everyday businesses, this technological bottleneck creates an immediate, lucrative opportunity. Internal business data has transitioned from a routine operational byproduct into a strategic asset. Businesses must begin treating their records seriously today. That means actively cleaning, structuring, and organizing internal databases so they are ready to be used as training inputs. The period of extracting free value from the open web has ended. Businesses that arrive at the next stage of AI development holding clean, private data vaults will possess a compounding advantage that latecomers will struggle to close.